Assalamualaikum. My name is Fatin Syabiha binti Azman. My ID number is AA17023. I am supervised under Dr. Sharifah Mazura binti Sheikh Mohsin in my Bachelor of Civil Engineering with Honours. This is my final year project presentation entitled The Outcome of Concrete in Application of Oleochemical Sludge Waste by Partial Sand Replacement. My presentation outline is begin with introduction to studies, the literature review, methodology, result and discussion, lastly the conclusion and recommendation. First and foremost, Malaysia is known of one of the biggest country in Asia which produce 1,000,000 tons of oleochemical plants. The oleochemical industry in Malaysia is benefiting from an uninterrupted supply of palm products. The oleochemical sludge waste is waste derived directly from oil mill effluent pond and recycle the waste, which is plant-based, into compost. As these wastes are organic in origin, they are rich in plant nutrients. Composting of waste generated from palm can be a good practice as it will help in recycling um, and helpful. This review deals with various aspects of waste management practices and the possibility of composting the waste. Next, the oleochemical substances have numerous uses of form and industrial products such as fatty amines, fatty esters, soup noodles, and metallic soaps. In this research, we use the sludge waste as substituent to concrete. This is the sludge obtained from FPG Oleochemical Sdn Bhd, which is located at Gebeng, Pahang. This we will use and conduct experimental work in form of concrete cube and concrete prism. The problem statement is the abundance disposal of waste to the environment, which will need more spaces and leave harmful toxic to the environment. Next, the need of study in concrete properties to investigate the suitability of concrete mixture with the waste. Lastly, the amount of moisture absorption of concrete in using oleochemical waste as partial sand replacement. The objective of this study is to determine the potential workability of concrete, to determine the optimum amount of water absorption of concrete, and to investigate the effect of compressive strength and flexural strength in concrete. The scope of study is the oleochemical sludge waste are obtained from FPG Oleochemical Sdn Bhd. The oleochemical waste are ground to the required size before use. The replacement by volume of oleochemical waste used as partial sand replacement are 0%, which is the control, 5%, 10%, 15%, and 20%. The specimen is in form of cube and prism sizing 100 x 100 x 100 mm and 100 x 100 x 500 mm respectively. There will be 75 samples that need to be tested. The samples for compressive strength test and flexural strength test are tested at the day of 7th and 28th, while the sample for moisture absorption test are tested at the day of 7th. There will be need to design MD of concrete with sludge waste by partial sand replacement. the concrete design to be 25 Newton per millimeter squared. The experimental works in concrete mix design will be based on experimental results of trial and error of 10% of oleochemical sludge waste replacement, which is we take as the optimum value. This is several of my literature review. Uh, the first research paper reviewed the strategy on maintenance to enhance reliability of nature and equipment, maintenance cost effective, boost efficiency and effectiveness of maintenance, improve workplace safety, and produce sustainable plant throughput. The second research paper reviewed about the disposal of oil sludge harming environment. An action to be taken into place is recycling of sludge as well as reconstruction of and demolition wastes and forms into building materials. The soil sludge were tested and analyzed by referring standard method in APHA 1999-8 according to that country. The third article is a review about the effect of dry sludge waste in concrete performance, physical and mechanical properties. Waste sludge material was replaced with fine and coarse aggregate in various percentage. This is the research methodology. Begin with the research title, statement of problem and objective, followed by the scope of the research and the significance of the study, and then the literature review, preparing the materials. After that, do the lab testing. Finish the testing, we will collect the data and discussion. Finally, conclude the research. The lab works include preparing the materials, which use cement, fine aggregate, coarse aggregate, and oleochemical sludge waste. For the sieve material, we will see the fine aggregate, coarse aggregate, and oleochemical. After that, we casting based on this MD in form of cube and prism. For curing, there will be for 7 days and 28 days, and collect the data for slump test, compressive strength test, flexural strength test, and water absorption test. The material is used is fine aggregate, which passing size 4.75 mm. The coarse aggregate is passing maximum size 20 mm. The oleochemical sludge waste, cement, water, and super plasticizer. This is the machine and machineries that you use in laboratory, which is oven for drying the sample, LA abrasion testing machine for grinding the oleochemical, the sieve shaker machine for sieve the material, concrete mixer machine, and testing machine for compressive is compression machine and test, and for flexural is universal testing machine. The result obtained for slump test in 0% and 10% such replacement. The picture shows the slump value for 10% such replacement. This is the several of concrete samples that are some unacceptable and some can be tested. For the compressive strength test, the value for 0% sludge replacement in 7 days and 28 days. For 10% sludge replacement, cannot we obtain the result. For flexural strength test, result is 0% sludge replacement for 7 days and 28 days. For the picture is flexural strength test of 10% sludge replacement and the result cannot be obtained. For my expected result should be obtained from experimental work is A, which is compressive strength test, compressive strength value concrete, the flexural strength value of the concrete, and the optimal amount of water absorption of the concrete by partial cell replacement using oleochemical sludge waste for 0%, 5%, 15%, and 20%. Firstly, the concrete in this study was carried out with adding potential oleochemical sludge waste by controlling the optimum percentage of waste concrete, which is 10%. Then proceed for the 5%, 15%, and 20% replacement with the same CMD with 10% replacement. But due to the limited time left, the experimental work proceed after third trial and error of 10% replacement. The testing managed to conduct during MCO time. The result obtained for 10% of failed. The concrete did not achieve targeted strength. So for result obtained for 5%, 15%, and 20% are also failed. The concrete oleochemical replacement did not achieve any result expected. For water absorption test, the result is also cannot be obtained because of limited of time providing to do the lab testing. No water absorption result expected required for 0%, 5%, 10%, 15%, and 20% replacement. In conclusion, the objective of this research cannot be achieved. The result obtained from testing cannot be used as the trial and error for 10% replacements and they did not achieve the best result. Due to the MCO, limitation of time provided for lab works and lab testing. In my recommendation, the experimental works and time should not be restricted, so the work can be done completely. To obtain better result, we can try to use lower percentage of oleochemical replacement to find optimum percentages. This is several of my references.